Let's look at practice quiz number 6 on exponential growth and decay. Number 1 says to simplify 4x squared times 3x. So this is the case of some exponent rules. So we just have a 4x squared times 3x. So you first want to just multiply the two numbers together and you get 12. And then we have x squared, which means x times x. And then we have another x over here beside the 3. So that gives us x cubed because there's 3 x's being multiplied together. That's it for number 1. Let's take a look at number 2. Identify the initial amount a and the rate of growth or decay as a percent of the functions below. So for this first one, the initial amount would be the 4. And for the second one, the initial amount would be the 1,000. It's the number in front of the base. Then I can tell that the first one would be growth because this number, the b value, is greater than 1. So I'm going to circle growth. And for the second one, b is less than 1. So that would be decay. And then it wants us to pick out the rate. So for that part, it might be helpful to rewrite the function to see the rate. So you can write p equals 4. And then instead of 1.5, it's growth. So it would help to write 1 plus 0.5. And then you can see the rate of growth is right there. It's the 0.5. But then to change it back to a percent, you need to multiply it by 100 or move the decimal over 2 places to the right. All right, so that would be 50%. All right, for the next one, we have 0.88. So let's rewrite the function. Y equals 1,000. Then it's decay, so it's 1 minus. And think about how much smaller than 1 is the 0.88. And you can figure that out by doing 1 minus 0.88, and you get 0.12. So that's the rate of decay, is the 0.12. And 0.12 as a decimal would be 12%. So remember, you can move the decimal over 2 places to the right, or you can multiply it by 100. For number 3, it says write a function that models this situation. Sales of $12,000 increase by 5% each year. So let's write y equals the initial amount of sales, which is $12,000. They increase each year by 5%. So we need to write 1 plus, and then change that rate to a percent. So 5% would be 0.05. Remember to move the decimal 2 places to the left or divide it by 100 when you're putting it into the function. So that'll be 0.05, and then we could put a little t or an x for the exponent. So to model the function, you want to make sure that you leave room for an output value and an input value. They're still there. You haven't replaced those with anything. All right, for the next one, it says a sound system valued at $900. So let's write y equals $900 because that was the initial amount. It says its price decreases by 15% each year. So the rate would be 0.15, and it's decreasing. So we need to write 1 minus the 0.15, and then you could put t for your exponent. So number 3, we're just writing the function. You don't have to do anything more than that. But just make sure to leave the y, which is your output, and the x, which is your input, or your t. So don't replace those with anything. Number 4 says the population of a city has been increasing by 2% annually. The current population is 316,000 people in 2022. Find what the city's population will be in 2025. So for this one, we need to set it up and plug in the time. So let's put y equals the initial amount of 316,000. It's increasing, so that would be growth. So we need to write 1 plus 2%, which is 0.02. And then we got to plug in time. So let's write, and you could just plug it in. I'm just going to write it again and plug it in so you see what I'm doing here. So time would be 2025 from 2022. So that's 3 years have passed in between those two. So let me grab Desmos to type that in. And you could just use a graphing calculator or Desmos. But if you use Desmos, remember it doesn't like commas. So I got to put 316,000, 1 plus 0.02, or you could type 1.02. And then I need an exponent of 3. So I get a population of 335,342. I'll go ahead and round up since we're talking about people. All right, so that's it for number 4. We just have one more to look at. Number 5 says you invest $2,500 into an account that compounds quarterly at 7%. How much will you have at the end of 10 years? So compound quarterly, that's when we need the A equals P times 1 plus the rate divided by the number of times a year it compounds to the n times t power. So that's our formula. We want to know how much will we have. So that's our final amount. So leave A. We're looking for that. The initial amount, which is P, is 2,500. And then we have 1 plus the rate, which was 7%. So we need to put 0.07 because 7% equals 0.07 as a decimal. I'll write that over there. The N is your number of times it compounds a year, and the N goes with quarterly. So quarterly means N equals 4. There are 4 quarters in a year. 4 quarters in a dollar, like you could remember it that way as well. So a quarter, it means 4 times. And then I'm going to put all those in green so you can see that the 4 goes in both of those places. And then time would be 10 years, so we need to put a 10. Okay, so then just carefully type all of that in the calculator again. So we have 2,500, 1 plus 0.07 divided by 4. So notice just that part is divided by 4, and then we need an exponent. And right there, I would go ahead and multiply these two together and put 40. Or you've got to group those two in the exponent with another set of parentheses. So it's easier to go ahead and multiply those before you type it in. So A equals $5,003.99. Since we're talking about money, it's good to put the decimal to the hundredths place since that's the number that represents the change. Like cents. Okay, so that is it for practice quiz number 6.